Good morning. Testing, testing. 龐家豪, I have just plugged a mic in the notebook. And could you please tell me the difference between the two? Now this one is with a if, and I would like to remove that. This one without a mic. What's the difference?
冇乜分別啊。
冇乜分別。You just spend me more than 100. $168. That means no difference. No difference at all, right? Incomes why do I need to spend that $168? Why do I need to spend that dollar? Anyway, I just want to make a difference. I try to see the difference between the two, but sadly, it tells you no difference. All right. Oh, today is day 4. Day 4. Day 4. Day 4. Now, first of all, we'll check your attendance first. 3, 4, and 5. Can you just put a cross? So what does it mean by that? No difference at all, you mean? And it's a waste of money of buying one microphone, in which you just surprisingly tell me no difference. So what's the point of buying that? What happened? I just intended to send you a file through the chat box, but I don't know why it doesn't work. And I can do nothing but do it again on the WhatsApp platform. Try to make it in the WhatsApp instead. So this is our inorganic chemistry QA. And this time, just like last time, I would like to check that in detail your answering technique, as well as some, of course, there may be some other follow-up questions that follow. Okay, so 陳景熙、龐家豪 here. 蔡仲常, are you here? I don't know why it cannot be sent. It doesn't matter. 蔡仲常 here, because I did not find your name onto the chat box. 陳浩熙, where are you? 陳浩熙, not here. 陳浩熙. I know. 蔡仲常, you did not change the format of the name, right? Such that I cannot find that. 張家榮 slept. 何展鵬 林家齊嘅麥耀南。
早晨，早晨。
潘樂之 ，Where's 潘樂之？哦，潘樂之。
喺度。
OK，蕭俊熙 ，and 蕭 not here。黃俊熙、鄭群威、Are you here？鄭群威 ，Wayne no，陳子軒，哦 not here。So I repeat, your presence is about 張家榮、蕭俊熙、鄭群威。Are you here? No. Have you received file? Okay, have you received file? Now, take a look. And we'll start from question 1. We will do the first half, okay? Because for this half is for Chem 1, but you can continue doing that by yourself. And of course, I would love to ask you something in detail about some technical way to solve. Now, because we are now having some oral instead of written. Now, so we need to do two things. One is check the written work. Second is about your oral. I will give you some follow-up questions based on practical sense. What I mean is in practice. If it doesn't help, what should I do next? Okay, because tomorrow you would have a QA session, you have to come back, right? So this is highly needed. Try to link up practice and theory. So do you know my purpose of the lesson today? Okay, so each one of you would have a chance to speed up. 陳景熙 Chemical test to distinguish between sodium thiosulfate and sodium sulfate. Add dilute surfactant. Yeah, and then what's next? And then the sodium thiosulfate to produce a yellow precipitate, while the other one gives clear solution. So the question comes, or you're asked to think of the chemical test to distinguish between them two. To start with, you have to tell me the stage. You first of all, before you ask anything, you are going to tell me the stage first. Okay, even though the question doesn't give you. So you need to be aware of this. So what should be the stage?
Write an aqueous solution.
Yeah, that's right. Can you see that? So that is the very first step. Solid powder. Can you see that? I just circled it for long. So here, okay? So this is not the first. The first thing is to dissolve it. Okay, dissolve the sample into distilled water to form a solution first. And second, the technical reason is that you are checking for the presence of PPT. Of course, you need to have a solution. Okay, the one which shows the formation of yellow. Instead of writing PVT, could you please write down precipitate? Okay. Now, so remember, some words is missing. Is the word gradual. Gradual. Do you know why? Right? This is because of the formation of the sulfur. Colloidal sulfur is somewhat a very slow process. So you are going to take a note on the presence of yellow PPD very, very slowly. Okay, they will form more, and you can do this, and you can tell this is sodium thiosulfate. So this one makes a difference between this and other yellow PPT product. Okay, because for the other precipitation, but for the other reaction is done by precipitation. So for the precipitation reaction is somewhat very fast. So all of you please mind it down. For if you want to talk about precipitation reaction, it is somewhat a fast step. So what does mean by that? A mixing of a solution and the PPT, they will rapidly fall. Okay, how about this case? For this case, it is the reaction between sodium thiosulfate and sulfuric acid, you mean, right? H2SO4. So what will be the product? Hey, could you please tell me the equation? What does mean? Yeah, that's right, sulfur. So can you balance the equation for me? Sulfur, sulfur dioxide, water, sodium sulfate. Now again, check for the 1, 2, 3, 4, 5, 6 altogether. We have got 6 chemicals. How come you just say the 1, 1, 1? How about sodium sulfite? Okay, there's sodium sulfate and what is sodium sulfate? And what? SO2 and what? And what? H2O. Okay, so have you balanced them? Now, go back to the observation. So for this part, you are not going to give based on the color. You need to give me what? Any other observable change. For example, gas, right? What is that? How do you describe the gas? Colorless gas. Can you describe the smell? Pungent. Bad smell. Or bad smell, is it? Bad smell, pungent, choking. Okay, choking smell. Refer to sulfur? No, actually not. Sulfur is not referring to bad smell. What is that? SO2. SO2, what is that gas? What does that smell like? Yeah, that's right. Why don't sulfur have a smell? Very big molecule, so it's not volatile. Can you get my point? It's not volatile. So the description of showing SO2 will describe it as a burning sulfur. Burning sulfur. The one which is the smell very similar to the air after the surrounding environment after having burning firecrackers. Okay, so you have this smell. But of course, somebody can also smell bad smell. So what is that? Bad smell, it is hydrogen sulfide, bad smell. So remember that two is different. Bad smell refers to hydrogen sulfide. Okay, is that clear? Now this is the question one. I don't think that you can finish that 12 questions so easily within an hour. How about second question, 周永成? Sodium sulfide and sodium sulfate. Sodium sulfide and sodium sulfate. Yeah. K2Cl27. So it seems many of you forgot the whole thing, right? The way to present the idea. First of all, the amount, how much chemicals they are needed. Yep, add a few drops. Purpose. Why do I need to use few drops only? And in large amount. Second is the term acidified. Acidified. Do you still remember? You forgot to tell the word acidified. K2SO7 to what? Is it solution or solid? Or both? Either is okay. Aqueous solution. How about solid? Is it possible? Will it turn the color change? If it is solid. No, until it dissolves. How about the others? So what's the point of having a for example, a breathalyzer, the traditional breathalyzer? It's a silica gel packed with solid, right, acidified K2SO7, and the people to just breathe out your breath, okay, and blow the breathalyzer and try to check for the color change, okay, from the alcohol content of the breath. You may judge, okay, whether or not there is a color change. So the answer is for solid is okay. So it's not this is not necessary to make it solution, but why do so many people love to use the solution state is because of the easy following up of the following process. For example, you want to test for the presence of precipitate, for example. Somebody would love to use the term to check for the presence of precipitate when you react with something else. So very often, once you were given the white powder, what are the very first steps? Many people would love to make a solution first. Okay, and the one which turns the dichromate, okay, from orange to green is potassium sulfite, while the one, how about the sulfate? How about sulfate? No color change, okay? So remember, we have to tell both observation instead of just telling me the positive result. So of course, you know what I want next is the equation. What is the equation? I will invite Pong Ga-ho to balance the equation. Do you have a pen? Your line is so thick. Yeah. So while we are waiting for that, right? Well, maybe most of you you are now doing such. I will invite some other people to stand by. Wang Junho, question 3. Try to prepare typing those answer, and we love to check. The chemical test to distinguish potassium iodide and potassium bromate. Yep, dissolve the solid in still water first. Remember to give a choice of the solvent, and then done for Hong Gao's part. Done, finish. Correct or not? Yeah, correct. Okay. So this is what I would like to remind all of you about the balance equation. And then add silver nitrate. And then what's next? So what is that? The other one. Yeah, or it is not necessary. The answer is you better make it certified, especially if you in practice, you would receive the white solid, which is unknown. It's unknown to you. So the certification plays a very important role. Okay, of course, if for this question, if you just based on this question to answer, if you omit the word acidified, the answer is still correct because you may have the two chemical, one is a pale yellow PPT, the other is yellow PPT. From the color, somebody will think that from the different intensity of the yellow part, you may judge which is which. Okay, but in reality, those white solid they are still unknown to you, so you have to acidify the silver nitrate before you use. That is point number one. I would like to share with you this part. And second is about the, in case you may find that it's rather confusing and it's quite difficult to judge whether or not is that yellow, right? Or just creamy. So what should you do is to have a confirmatory test. Any confirmatory test. Any confirmatory test. Ammonia solution of different concentration. So what is mean by different concentration? Try to give me some technical way effectively. Dilute and corn. Add corn ammonia. Add corn ammonia to what? To what? Ki doesn't dissolve in corn and dilute ammonia solution. Of course not. Ki is water soluble. What do you mean by that? Is it Ki that remain not soluble? Yes, the PPT. So maybe most of you have got the answer, right? The one which dissolves to form a clear solution is what? Silver bromide, while the one which remains undissolved is silver iodide. But the question comes, but now this is Ki and KBr, not AgCl and AgBr. It's bromide and iodide. But the question comes, then let's talk about something technical sense. In case you have got some powdery things, you want to check the solution. What should I do? Now this is the technical way you need to have. Some cloudiness, right? So what should you do? You are going to pour it until 1/10. Pour away most of the chemical until 1/10. And then add so-called ammonia in excess and try to check. Okay, do you understand? Why? Why do I need to pour the solution until 1/10? Or maybe even less? Do you know? It is something about the saving of chemicals. Do you understand? Because you are going to look for only the dissolution process. So if you have got such a large tube of the chemicals, if you add so-called large excess of the corn ammonia, so what is the consequence? Okay, it will easily spill over, but still the dissolution may not happen. Okay, so it will lead to some confusing result to all of you. For example, false negative result. Okay, you get my point. So remember that principle holds for all other precipitation reaction for following up. What I mean is, if you want to do some action to reconfirm the presence of the nature of PPT, very often we use that techniques. We want to think of redissolution process. Please just keep little sample. By doing so, whenever I pour the chemicals there, for example, I pour half of them is still in large excess. Can you get my point? But once the chemical, they are already of that amount, such like already 1/3 or maybe half of the tested. So you may need much more chemical in order to make the dissolution process happen. Okay? Can you get my point? It's not just saving the chemicals, but also to avoid the false negative result from happening. Do you understand? 你明我講乜 ？Now and
Yes, but
else?
Mr. Chen, excuse me，我想問翻咧，即係其實我哋點解唔將佢嗰個嘅嗰個開嗰個 potassium bromide 同埋 potassium iodide 嗰個分量開少啲，咁咪唔使之後咁咪唔使擔心又要再倒過佢咯。
對於你哋嚟講咧，唔會咁做嘅。當我俾緊你嗰陣時咧，我俾緊一啲有限嘅資源嗰陣時咧，你當無限咁諗咧，通常啲人就會好多噶啦。所以咧，同學，你頭先咧係一個 at the very beginning 可以做嘅 techniques 嚟嘅，即係你唔好整咁多啦咁樣。但係咧，好多人就成日驚自己睇唔到，咁最後會點咧？你就會加好多嘅。係啊，我見好多嘅你哋啲師兄咧個做法都係㗎啦。你驚自己睇唔到啊嘛，要整好多咯。越整得多嘅話，你越倒得多。咁呢個係 it is not so proper， and 亦都係好容易會 lead to some negative false negative results. So this is what I'd like to remind all of you. And one more on the test. If you really know, if you can really narrow down it as a yellow PPT that may be silver bromide and silver iodide, you can also add what? Alternative, you can also add what one chemical?
Was it like zinc something?
Zinc?
Zinc night? I don't really remember.
Nitrate. No, not zinc is lead.
Oh yeah.
Lactyl nitrate. Why? Because for the lactyl nitrate, we have got two consequences. Because lead, they would easily form precipitate with halide. Okay, but the color is much different. For lactyl bromide, it is still in terms of a white PBT. But if you want to have a lactyl iodide, they will give you a very bright yellow PBT. Bright yellow, very beautiful color. So if you want to get to know what I mean, you can check on the YouTube to get to know what is meant by golden rain experiment. It makes use of the formation of lactyl iodide, and this is somewhat one of the techniques in info day mode again. Chemical test to distinguish the calcium carbonate and calcium sulfite. How? Now both you've got carbonate and sulfite. 有邊個未答啊？劉允晶？劉允晶？And add organic solvent and shake the mixture to observe the color in question 3. Question 3. And add organic solvent and shake the mixture. KMNO4. Why? Why do you add KMNO4? Why? You want to look for red dots, right? Iodine bromide will form its element state, and dissolve the sample with distilled water at bromine reduce. Each sample, the sample transfer to the I see. Now that be aware of the fact that the two chemicals, bromine solution in aqueous, right, is brown, while your iodine solution is also brown. So, and you are going to have a merging of the two answer. You use the 唐家豪 one and merge it with 蔡仲常, and you can get what I mean is you can have if you want to have a red dots such like bromine water or chlorine water. Even though chlorine water is also okay. If you use chlorine water, of course, both will give you something brown solution. And what you need to do is to, and then put it into a organic solvent like this. Okay, organic solvent. Just give me some example of organic solvent and check for the color of the organic solvent there. So if it is bromine, what is that? It is in orange. While for this, it is iodine, it is purple. Okay, so this violet. So you use this for help to judge. Clot reaction. How to make clot reaction for Hong Jinpao? How to make clot reaction? So if you use, I don't know whether or not you are using that proper chemical before we judge the use of chemical. Let us try to compare. Let us try to stress once again the significance of having chemical tests, right? What are the characteristics of a chemical test? They should be fast, efficient, easily observable. Okay. When you use clot reaction, you may take you quite some time, a small fixed amount of our sulfate starch solution. All right, you wait for some time. So it is when you compare with the other simpler chemical test, okay, we will not prefer using it because you need to wait for a longer time. No need to mention your method will require more chemical. Okay, and then according to green chemistry, we'll not use it. So it's not just practically feasible and choose this, and we need to choose the one that is most efficient one. Okay, most effective method for you to come to arrive at the answer. So this is question 3. Can you get it? Question 4. Question 4.劉文正, where are you? 劉文正. How about 麥耀南? Chemical test to distinguish between calcium carbonate and calcium sulfide. 2 of you, are you here? 麥耀南. Where are you? Not here. So shall I invite some others to help? And yeah, Magula, tell me your answer. Plus water. So what's next? Plus water. What's next? Bongao. Nothing happens. Something happened, or did nothing happen? So what is that? Add water to it. Both are water insoluble. And second, we are looking for chemical test. Chemical test. Okay, so let's look at Wing's work. Add dilute hydrochloric to the sample, collect any bubbles and pass through the lime water. Carbon is present in the sample with lime water, also contains calcium sulfide. You may have that. Agree? How about the others? Agree? Or CO2 is given out. So even though you use lime water, so what will happen? So if you use the lime water, again, it is not a good choice. But of course, if you think in reverse, if you do that action in carry out in practice, that is the very common technique. you use lime water, right? I add hydrochloric acid and collect the test the gas. So the answer is both gases, they will turn lime water milky. Okay, both gases. What I mean is CO2 and SO2, they will also turn it milky. Okay, so what you need to do is to do somewhat what we call it as a confirmatory test. Okay, to test for the what? Reducing property of SO2 should be exhibited. Okay, so can you get my point? So in written, the answer is, now you have got two versions, the answer of two versions. First version is the written answer, exam-like question, is to add dilute hydrochloric acid to the sample, collect any gas, and pass them through what? The acidified potassium dichromate solution. Or if you have bulk, 又係土豪嚟嘅你哋，點解你哋好中意 pass the gas through 一啲 chemical 嘅？土豪嚟㗎，知唔知點解咁土豪啊？你哋 ？Yeah.
Because first, not all of the gas would react with like the lime water.
Because you simply think that we have got abundant resources.
You'll need a lot of it in order to actually produce an observable change.
Yeah. How about the instead of bubbling the gas into the solution, you may think of alternative. 要諗埋啦，依個真係真係做 SBA 嗰陣時，你唔會要俾咁多㗎。我唔會俾幾百 gram 嘅 chemical 等你哋走嚟 test 㗎。你頂多得一羹㗎咋。你明唔明我講咩 ？Yes, filter paper。你呢個咧就係 practical sense 嘅答案啦，就係你要攞個 filter paper，soak with K2Cl27 2 minus acidified, right? That one to test for the color change, whether or not it will changes color from orange to green. I know that is SO2, and I know that the ultimate sample is sulfite. For CO2 one, there will be no color change. Can you get my point? So we try to make this into practice. Okay, number one, I try to start from Wayne's work, and this is what you know in practical sense. And 如果真係做嗰陣時，你會點做咧？你唔會咁搞笑咧，一開始就做 filter paper soak with dichromate 㗎 ，acidified dichromate 㗎。好多人個個都係會做 lime water 先嘅，你知唔知點解？因為快嘛，人哋覺得快嘛，咁所以咧留意住你話 carbon 嚟加酸或者 收費加酸出氣體去試咧，好多人好快係諗 lime water 話俾你聽，好多人都會諗 lime water。不過又係嗰句啦，the same condition situation is that the resources are limited， 大概1到2個 spectra 㗎咋。你每位同學可以分發到咁多嘢嘅，所以未必真係可以做得到嘅。嗱咁所以咧你要諗 try to think of it in practice. How can we do this reaction? You understand? 真啦，你聽日你 feel 到你就明我講乜㗎啦。資源有限嘅情況底下，你會點做 ？How about question 5？仲有邊個未答？好，陳龍喎。 lead to nitrate and zinc nitrate 又係啦 ，solid 嚟㗎。所以第一步萬能 key 答案，第一步係咩？ OK， 第二步 how much？ how much？ Yep, add dropwise until excess. So once you just said so, you are going to give me the observation of both scenario, dropwise and excess. 兩個都要講啊嚇。Both, first of all, both samples. Huh? The one will give white PVD only, which is lead to nitrate. So it depends. Go back to the question, Chan Long Wong. It depends on how much ammonia solution is added. Okay, so can you see the whole flow, the way to answer? Okay, in the excess ammonia is what? 邊個係打邊個 ？Is zinc. Yeah, the zinc nitrate. While the does not is lead to nitrate. So what is the chemical principle behind? It's the complex formation. So the zinc oxide, hydroxide, and lead to hydroxide is formed with point number 1, white PVT. Point number 2, in excess, they will form, what is that? With no complex form, but for zinc, they will form a complex, we call that tetramine zinc ion. Okay, it is in form of water-soluble substance. Okay, is that clear? So again, some technical issues. 又係啦，如果你要試 PPT 嗰陣時點啊 ？Just pour away those chemicals until maybe 1/10 is left behind. What's next is to do the following action. You add it with alkaline and more ammonia to see if redissolution occurs. Cheng His work can add sodium chloride solution. What do you think? The answer is yes. Why not? But you have to keep the first step. Dissolve the soil sample into water. Second step, add sodium chloride solution. So what will happen? One of them will show white PVD. The other one is not. For those is white PVD, I can deduce it is lead 2 ion containing. The other one, no observable change, is the zinc nitrate. So clever, okay? But in practice, 又係啦. But in practice, while you'll be given some white solid, you'll be very eager to identify the cations, right? So adding alkaline, NaOH or ammonia solution respectively is a common choice. 好多時我哋都會加減嘅，因為尤其是由白色粉開始啊。We don't know the identical cation. So very often you use this。即係呢個情景嘅答案係咩嚟嘅？呢個考試答案嚟嘅，明唔明啊？考試答案。但係喺實驗室入邊嗰個做法咧就係點樣咧？咁其實就係你試 K 人咧，你就係通常都係做呢兩個嘅啫。第一個方法係咩啊 ？Flame test。The other one is what? Ending with alkaline. Produce a solution ending with alkaline. It's different. Okay. How about question 6? Chemical test to distinguish between aluminium sulfate and zinc sulfate. I would like to invite the latecomers to answer this question. Zhang Gaowei, what is the time? Tell me. You just come back punctually. If it were the Bangkok time. 曼谷時間嚟喎，張家榮。It's now 11:05 Hong Kong time. Beijing time. Tell me. Chemical test to distinguish between aluminium sulfate and zinc sulfate. How will you do that? Do the similarly, right? To both sample. John Gordon, no marks. Do you know? No marks. Do you know why you can't score any marks? Because you do not know the sample being a solid powder, similar to Thomas. Solid yes. Even on Jinpan can tell you are going to dissolve the sample in water first, and then do the precipitation. And if you go back to your case, adding ammonia or sodium hydroxide, you have got two cases. The first one, if you add ammonia solution, again, that is a zinc hydroxide, the PBT, they will be dissolved in excess ammonia to form this complex. How about NaOH? How about NaOH? Yes, can you get my point? So for very similar procedure as question 5, you use ammonia, it's okay. For NaOH, it is not correct. Why not? Now, because both they will form zinc hydroxide and lacto hydroxide is initially if you add little NaOH, but you add it in excess, NaOH, what will happen? They will form what is that? Zincate and plumbate, respectively. Okay, so these two they are also in form of a water-soluble complex ion. So NaOH, no. Ammonia, yes. Is that clear? Okay. Zhang Gaowing, do you know that when you're going to do that in practice, we need one techniques. Save chemicals. How? I want to do that action. What should we do? You want to check for the redissolution, right? 應該點啊？唔好嘥 chemical， 咁應該可以點樣做啊？唔嘥 chemical 好有效咁睇到 redissolve， 有咩方法？唔識啦已經。好，咁我揾上咗1個鐘頭嘅同學仔答啦。係啊，陳浩希。Tilt a bit. 係啦，茶會啱啦，茶會希都識答啦。咁啊，賭剩1/10啦，得唔得？賭剩1/10去試，唔係打側佢啊，唔該。賭剩1/10，咁你就好 sure 咧，就即係你確保個 false negative result 嗰個 chance 係最細㗎啦。OK， 明唔明？好，第7條。似乎我哋應該去到第8條嘅今次。好，第7條。Chemical test to distinguish between ammonium chloride and sodium chloride。嗱，又係啦。頭先都講咗啦。如果你去嗱有考試答案同埋真實做嘅狀況啊嘛，係嘛？真實做嘅狀況係咩咧？就係、可能是 flame test， 你覺得有 golden yellow flame 啦，係咪？咁但係咧，我話俾你聽咧 ，even 你做 ammonium chloride 咧，或者你試好多隻 sample 都好咧，we would also experience that moment where whether it's golden yellow. Why? It's because while the indeed is not platinum wire, right? What I give you is just nickel wire. While I heat it strongly into the Bunsen flame, they will give you something yellow, the yellow flame. So it will be quite hard to judge whether or not that golden yellow is really golden yellow, or will it give you any obvious color change? Okay, so this is what you may need to tackle tomorrow. Take a look on the answer first. It's somewhat written. Chen Qinghe is so good at it. In theory part, in written part, in examination situation. This of example is this water and that sodium hydroxide solution and then hot. And what? And what? And alkaline. You want to add an alkaline? Now, the whether it's solid or liquid is also possible, right? You can simply add alkaline. And NaOH. But remember, that alkaline must be sodium hydroxide or potassium hydroxide. Never put ammonia into it. Can you get my point? Once I add ammonia to it, I heat it, and you would, of course, both samples will give you ammonia gas. So can you trust that both samples contains ammonium salt? Okay, so this is another important technique to address. You are producing somewhat false positive. You know that during COVID-19, we love to talk about false negative, false positive result. Okay, so remember, I add, if anyway, remember to warm it. No need to heat it strongly. Warm it. Gentle heating can help. And this one, ammonium chloride, they will produce some pungent gas. While for this one, no observable change. But keep calm. While in practice, you are going to do it in front of me, objective, in a very objective way, to tell us it is ammonia. How? Yes, do it very, very seriously. Pick up a what? Moist, red, litmus paper, and then what? And then check for the color change, red to blue. Oh, I know it is ammonia. But wait a minute, Mr. Shin, isn't it very smelly, just like urine? Yeah. So it is a very important clue. Remember, while you do the experiments, be observant. Observant doesn't mean it's not just telling you visually, okay, but also smell, etc. So this is what I would like to remind all of you. But how can I know whether the sample reacts with solid? Even solid can react with, even both of their solid, they can react. Okay, if I warm it. If you don't have it, of course, in your lab setting, we love to use NaOH AQ instead. It's also okay, no problem. And on the bench, you'll be given AQ instead. Okay, so you will use AQ and then dilute or ammonia or corn ammonia Without warming, the answer is, what do you think? I want to speed up the reaction. I want to speed up the reaction, so that is necessary. Number 8, the last question. Zhang Gaowing, you have skipped a lot. Tell me how to distinguish between sodium hydrocarbonate and sodium carbonate. Slept again. How? But I will see it as chemical test. First of all, I add X to it, both will give CO2. Even though I test it with lime water, both will turn milky. But calcium hydroxide, solution to what? Dissolve in water. What is the sequence? Tell me. What is number 1? What is number 2? What is number 1? What is number 2? Number 0. Number 2. So where is number 1? Do you know how to count? You cannot count this 0. Okay. First of all, as a kindergarten kids, they don't know anything about 0. Add lime water to solid, and then dissolve in water. I cannot comprehend. I cannot comprehend. So to start with, that is the first step. First of all, make a difference. What I understand, this one, we call it 1. Okay, this one I call it as 2. Okay, try to have a definition first. I don't know whether or not we are now talking about the same thing. Okay, this is 1, and this one is 2. Okay, so hey, do you understand? This 1, dissolve the sample in water, and this is to our understanding is not is 1. We make it 2. Do you understand? Okay, it's 2. It's the first letter first number come after 1. Okay. So dissolve the sample with water, and second, add this. And you are looking for the calcium hydrocarbonate being clear solution, and the calcium carbonate will have got a milky solution. Can you get my point? Okay. Your 1 is not 1, your 2 is not 2, or maybe you get it wrong, right? What you think that it is 1, it is indeed 2 in our eyes. Okay, we just stop at here for the question 8. Any questions so far? Can you get to know our way to solve, right? It's time to carry all those in practice. Think of the schematic flow. If I will be given some white unknown solid, and no one tell you what may be the cation, what may be the anion. So you have to think of a schematic flow, the sequence. Okay, just like those people studying ICT, and you can get what I mean. Any questions so far? 7.5. How about the others? 6. How about the others? Somebody say 7.5, 5 to 6, 7, good. So tomorrow I need to have a look on your practical work. Okay, that's okay. I'll see you guys. Bye-bye.